Hey there, young physics detectives. Welcome to today's Explainer. I'm absolutely thrilled you're here because we're about to go on a seriously fun journey. We're going to uncover the hidden physics going on all around us in just our everyday lives. You might not even realize it, but every single time you walk to the park, or run, or hop on your bike, you're actually performing some pretty amazing science experiments. So get ready, because we're putting our detective hats on right now.
Okay, right off the bat, let me ask you a bit of a mind-bending question. Are you moving right now, even if you're sitting perfectly still in your chair watching this? Just take a quick second to think about that. I mean, you feel still, right? It's not like your chair is zooming across the living room, but as a physics detective, you've got to look just a little bit closer. Because the answer is yes, you are moving, and you're actually moving extremely fast. Even when you're sitting totally still, the Earth you're sitting on is spinning on its axis at thousands of miles per hour, and the whole planet is zooming right around the sun. This is a massive secret in physics. Whether you're moving or not depends entirely on your point of view. Scientists actually call this a frame of reference. Now, to actually prove we're moving, we need something called a reference point. And a reference point is simply a starting place or just some object we use to measure if something else has moved. Like, let's say you're leaving your house for a bike ride. Your front door, that's your reference point. As you pedal away, your distance from that front door gets bigger and bigger, which proves you are officially in motion.
All right, moving into our first topic, distance versus displacement.
To solve our first big physics mystery, let's use a scenario we all know pretty well, riding a bike to school. But before we hit the road, we need to learn a cool science word. Ready? Scalar. Now don't let the fancy word trick you. A scalar is really just a measurement that only cares about the number size. Basically, just how much. Think of it like a pedometer tracking your total steps, or counting how many times you push the pedals on your bike. It doesn't care where you go, it just cares about how much you moved. But then we have the vector. Now this measurement comes with a bit of a superpower. A vector is a measurement that cares about how much and which way. It tells you the total amounts plus the exact compass direction you're heading. So it's not just taking 10 steps, it's taking 10 steps straight north. So how does all this apply to your morning bike ride? Well, distance is your scalar. It's that long, winding bike path you take through the neighborhood to avoid the busy streets. It counts every single inch your tires roll over. But displacement? That's our vector superpower. Displacement is a perfectly straight line drawn right from your starting point at home all the way to your ending point at school. Basically, exactly how a bird would fly. Let's actually test this out with a quick trip. So you leave home, pedal your bike a really long distance to the store to grab a snack, and then you ride all the way back to your exact starting point at home. You pedaled a huge distance, right? Sure. But because you ended up in the exact same spot you started, your displacement is, wait for it, literally zero. Your straight line distance from start to finish is zero because, well, you never really left your start line.
Next up, speed versus velocity. Are they the same thing?
Let's figure out our pace. Speed is simply the distance traveled by an object in unit time, or in everyday English, it just means how fast you're moving. If you pedal a really far distance in a super short amount of time, boom, you have a high speed. There's actually a simple math formula to figure this out, but seriously, don't let the math scare you. It just means speed equals your distance divided by the time it took. So if you rode your bike for 10 meters and it took you 2 seconds, you just do 10 divided by 2. Your speed is 5 meters per second. Pretty easy, right? But hold on. What happens if we give speed a superpower? Remember our vector from earlier? Well, velocity is simply the speed of an object moving in a definite direction. If you take your speed and you slap a compass direction onto it, it completely levels up into velocity. Let's lock this in by putting them side by side. Remember, speed is a simple scalar quantity. It really only cares about how fast you're going. Velocity, on the other hand, is a vector quantity. It wants to know how fast and exactly which way you're pointing those handlebars. So let's look at a crystal clear, real-world example here. If you look down at the speedometer on your bike and it says 10 miles per hour, that is your speed. But if you tell your friend, hey, I'm riding 10 miles per hour north toward the school, well, you just gave them your velocity.
All right, section 3, speeding up and slowing down.
Think about that bike ride one more time. You don't just magically travel at one single constant speed the entire trip, do you? No way. You speed up, you slow down, and in physics, that brings us to acceleration. Acceleration is defined as the rate at which your velocity changes over time. Put simply, it's just what happens whenever you change your velocity.
So naturally, there are different ways to accelerate. Step 1, you pedal super hard to speed up as you go down a hill. Your velocity increases, that is positive acceleration. But then, step 2, you see a stop sign and you hit the brakes. Your velocity decreases. In physics, slowing down is actually called negative acceleration or deceleration, as you've probably heard it called. You're technically still accelerating, just in the negative direction.
Finally, let's talk about motion in a circle, which is honestly a bit of a sneaky physics trick.
Let's take a quick detour from our bike ride and make a stop at the playground. I want you to imagine you're spinning on a merry-go-round at the park. You're moving at the exact same constant speed the whole time you're on it. But here's the trick. Velocity changes when there's a change in direction. Even though your speed hasn't changed at all, because you're spinning in a circle, your direction is constantly changing every single second.
And this brings us to a pretty mind-blowing fact. Because velocity is a vector, and your direction is always changing on that merry-go-round, your velocity is always changing too. And what did we say happens when your velocity changes? You're accelerating. That's right. Moving in a circle means you are accelerating, even if your speed never changes. Wild, right?
Oh, and speaking of circles, remember our old friend displacement? If you do one full, complete loop on that merry-go-round and end up exactly where you hopped on, your total displacement is a big fat 0. You traveled a distance for sure, but your straight line change in position? Absolutely nothing.
So to wrap up our everyday journey today, I want to leave you with a fun little challenge. If you stand up, run to your kitchen to grab a glass of water, and then run back to your exact seat right now, your total displacement is 0. But because average velocity is calculated using displacement, what was your average velocity for that trip? I'll let you physics detectives figure that one out on your own. Thanks so much for exploring the physics of the everyday journey with me. Stay curious, keep asking questions, and I'll catch you on the next explainer.